Hi, everyone. We're going to get started in just a couple of minutes.
Komal, can you hear me at all?
Hey, Steve. Yeah, I can hear you now.
Okay, good. Because that's a full system reboot to get me back on track
Okay.
here. I was hoping you can, otherwise we're in trouble.
Nope, it worked out. Okay. All right, we're just going to wait for everyone to kind of join in here. And then, Steve, can you see my screen?
Yeah, I sure can.
Sweet.
Not sure what's going on here. Yeah, I mean, quite a problem.
Okay, let's see. Okay. All right, we have a couple of people in here. So I think with that, we can get started. Hi, everyone. Welcome to Always Coding, our weekly Hacky Hour. If you've attended Hacky Hour in the past, welcome back. If not, Hacky Hour, it's just a pun on happy hour, and you're welcome to grab a drink or a snack, anything you like to accompany you while you're learning. And today's topic is all about working with CUDA and the NVIDIA Jetson on the alwaysAI platform. So we're going to get started. Before we get started, actually, let me introduce myself. I'm Komal Devjani. I am the developer advocate at alwaysAI. And Steve, would you like to introduce yourself?
Yeah, I'm Steve Griset, and I'm the CTO at alwaysAI.
Okay, thanks, Steve. All right, so we can get started. So let me share my screen, and I'm just going to kind of walk everyone through how to set up and use the alwaysAI platform. So what you want to do is go on alwaysai.co, and then you want to log into your account. If you don't have an account, you can sign up by clicking sign up now, and then it'll just ask you to confirm your email address, and then you should be good to go. Once you're in, the first thing you will see is the alwaysAI dashboard. And today we're just going to go ahead and create a new project. I'm going to show you how to install the CLI and run a object detector model. So we're just going to call it Hacky Hour Object Detector. And we're going to go ahead and create project. And as you can see, the project was created. So we're going to click to view our project. And from here, once you're in the project, you can download your CLI for Mac or Windows by clicking this button here. And it's going to give you an unidentified developer warning. You're just going to bypass that by opening the app in Finder and then click open on the pop-up. So if you can see here, we have this model loaded on here. So that's not the model I want to use. I'm going to go ahead and delete that. Am I sure? Yes. So from here, we're going to create a new model or add a new model. And then we're going to go into the public model catalog. And we're going to use the object detection model. And some of you might have seen this in the past. If you've seen me demo before, I really like the MobileNet SSD COCO model. So we're going to go ahead and click that and add that into our project. So Hacky Hour Object Detector, and here we go. We're ready to go. So let's go back into our dashboard, actually, and pull up this project so I can show you how it works. And if you're just following along, everyone should be able to follow along if you have the CLI downloaded. And then once we're here, let's go and open up our terminal. So let's create a new one. And then I have created a alwaysAI directory that I use. So we're going to go in there, and then I'm going to go into the alwaysAI starter apps. And then once you're here, as you can see, when you first download starter apps, you have all these starter apps available to start using immediately. We're obviously going to use the real-time object detector, so we're just going to go in there. And then what we can do here is copy this command and paste this into our real-time object detector. So that's going to create the project for us. And as you can see, it's found the app.json file, and I want to save this on my local computer. And then from here, what we can do is, if you haven't already downloaded this model, you want to just copy this and paste this into your CLI command, and it's going to fetch the model from the web. So I've already loaded this model, but I'm just going to show you what it looks like anyway. And as you can see, it's pulled this model here, the MobileNet SSD, so we're good to go. And just to confirm, we're going to make sure that this is added into our app.py file. So open up an IDE, And yep, it's added in here. So we're just going to control save this and then start the app. So we're going to do AI app install here on the CLI. And then we're going to do AI app start. So we're just going to copy the streamer and paste it into our browser like this. And as you can see, you can detect me, person, it can detect the potted plant on that stool in the back. And if I move my my laptop, it can detect the plant right here as well. So no shortage of houseplants here. And we're going to stop this now and move forward with our presentation. So I'm just going to set Steve up to demo what it's like to work with CUDA on the NVIDIA Jetson using the alwaysAI platform. So let's just go ahead and get started. And so before we talk about CUDA, I think it's really important to address the differences between a CPU and a GPU. So a CPU typically has a small number of cores, so a few cores that are optimized for serial sequential processing, whereas a GPU has a parallel architecture that can have hundreds of cores that are capable of performing tens or hundreds of threads or different tasks on each core. So you can theoretically have thousands of tasks being performed simultaneously in parallel. And matrix operations for deep learning are typically done in parallel. So that's why we see GPUs being leveraged for AI inferencing and AI processing. And typically, a lot of these tasks can be done much faster using a GPU. So let's look at some of the GPUs we use here at alwaysAI. So we use all three. We can use all three of these GPUs available from the NVIDIA Jetson ecosystem. So we have the NVIDIA Jetson Nano, the NVIDIA Jetson TX2, and the Jetson Xavier NX. And if you look here, so this gives you just the performance, like what its processing power is. So for example, a Jetson Nano has 0.5 teraflops, Jetson TX2 has 1.3 teraflops, and the Xavier has 6 to 21 teraflops. And this is where really it gets interesting. So this, as you can see, all of these have over 100 cores. So it scales up from the Nano to the TX2 to the Xavier. And the number of cores really defines how quickly a GPU can process the specific tasks. And the beauty of CUDA is that it also uses the CPU on these GPUs. And the program that you push into the GPU are basically stored in their CPU. And this just also gives you some information about the memory available with these GPUs and the power consumption as well. So you can kind of measure out what kind of power consumption your application has, if you have any restrictions of power consumption. So this is really important in selecting what type of GPU you want to use in your application. So now let's get into it. What is CUDA? So CUDA is a compute unified device architecture, and it allows you to program two processors with just one program. So how it works is CUDA can split the program, so you can run it on a GPU and a CPU. So what CUDA does is that it assumes that the device, the GPU, is a co-processor to the host, which is the CPU. And it also assumes that the host and the device, so the CPU and the GPU, have separate memories. And they interact with each other in the following ways. So the CPU runs the program, and it sends directions to the GPU and tells it essentially what to do. So it does this by, one, moving data from a CPU to a GPU, and it can go in reverse as well. So it can move data from a GPU to a CPU. The CPU can also allocate memory onto the GPU. And the fourth thing is, which is where parallel computing comes in, is CPUs can launch kernels into the GPU, which basically invokes programs on the GPU that compute tasks in parallel. So as I mentioned earlier, GPUs with hundreds of cores, where each core is processing multiple tasks, maybe tens or hundreds of tasks with each core, all of them can be done in parallel. And when you write a program for one data element, a CPU can automatically distribute that program to hundreds of cores with thousands of potential threads and thousands of tasks being performed simultaneously. And that's what gives you the high-speed parallel compute environment with the APIs. And then finally, CUDA gives you a software layer, which gives direct access to the GPU's virtual instruction set and parallel computational elements from the CPU. So, Steve, I hope that that sets you up pretty well for.
Of course it does. That was quite good. CUDA 101 by Komal. Very good on it. So let me go ahead and let's go to the next slide. Okay. Pretty much. So basically, there are two ways to work with the Jetson family of devices. And one is they have a CUDA-based software, as we've talked about, and it has a set of APIs. And so when we first started working with the Jetson family, our decision was to work with the CUDA-based system. There's another one that we're going to show next week, and as part of a webinar we're doing with NVIDIA on and I think that's the 17th, right, Komal? On that, and Thursday. On the 17th, and then in the afternoon, we're still going to have this hacky hour. That's going to be focused on something called Tensor Rt. So we have the CUDA interface and the Tensor Rt interface. So the Tensor Rt piece, so let's go to multivariable calculus and what we remember from that. So we got taught on a set of problems with multivariable. You have optimization and maximization. So optimization is where you try to get the best performance across a whole set of things or variables. And that's what we did with CUDA. We wanted to make sure that our model catalog could load across everything. So the current model catalog could work with the GPU on different types of models. Now, what happens with Tensor Rt is you actually have to compile the model and script it, and it's what we call maximization problem. So you take that in and it will maximize for different architectures and types of systems. And there's some nice little, what it really does is what we call quantization and compression in the model to run, as well as memory allocation. It does that piece on it. So it's highly maximized. So we're going to show you that thing. A Tensor Rt model or system will not run on anything else, where the model catalog, all these will still run and across any other devices you want to work on. Like if you want to work on your laptop, then go to the edge device, it'll be fine. You just have to switch one parameter, and we'll talk about that. The other fun thing we're going to have today, and I want to talk about, it's a little nuance, and I'm going to show you how to work around bugs that are going to happen. So we have been working to get on some, so Jetson at its core has something called a Jetpack, and it comes when you download their OS image. Before 4.4, what NVIDIA was doing is if you had to upgrade, you had to flash the memory. So there was no what we call Debian or OS package for it. It actually came as part of the OS. So right now we've had a transition into 4.4. Now what's unique about 4.4, it actually becomes part of what we call the Debian distribution that is down there for their OS, so you can upgrade it and so forth. The problem is before that you couldn't. And so what we're going to see today is alwaysAI released its 4.4 support, but it breaks going forward unless you're going to update your OS. And so the good news is, guess who hasn't updated their OS and sitting back on Jetpack 4.2? And I found this out beforehand. That's me. So I'm going to show you how to work around. I'll show you what the problem is, and then I'll show you how to work around it. So I guess that's the good news today. I'm going to have a failure. Now, the other pieces we want to talk about, we have convolutional neural networks. That's what I mean about CNN. I don't mean the broadcasting network or whatever it is. I mean convolutional neural networks. And we always call these primitives. So there's really 4 base ones that we worry about a lot in computer vision. That's image classification. And just as a quick reminder, what is image classification? Well, image classification is where I look at an image and I say, well, I see something out there that I'm looking for, right? And so, for example, in this one, they see the ball cup and so forth. The next one is something called object detection. And object detection not only can see images, but they can also identify where they're at. And so they draw the bounding boxes around it, as we can see in this example slide. So, and it's going to feed back the XY coordinates of where that device is. So if you hook it up with something like a spatial camera and things like that, you can figure out exactly where, or use some of the SciPy libraries. You can also do that too, relative, not to the exacting of a depth camera. The next one is something called semantic segmentation. This is what your autonomous vehicles are using. So what a semantic segmentation does is it actually goes through and looks at each pixel and classifies each pixel in the image. So it's not going down trying to find, using some type of technique to go through and find objects. It's going to classify each pixel to an object. Now, the other thing that's very interesting about semantic segmentation, where the first two I talked about, image classification and object detection, is that they actually ignore background. They are trained, as we do machine learning processes, we train them to ignore background. In semantic segmentation, you can figure out why this is important if you're doing autonomous vehicles. We don't ignore background. We want to know that the background there, what's going on with the background. So we want every pixel classified. So background becomes part of it. Now, the last one, and one that we haven't, well, if you download the code, you get to get our prototype that we're working on, is something called instant segmentation. Now, instant segmentation is kind of a hybrid between semantic segmentation and object detection. It's going to ignore the background like the first two, but it's going to find the object, and it also will uniquely find an object. So it knows that, like, it has two cups there, or two, I guess those are cups. I can't see, I'm getting old, but two cubes there, and it knows how we'll do them to different colors and so forth. So not only identifies an object, but it can uniquely identify the object. Now, the reason we're going here, and I promise we'll try to get this in the future, is I think David Dodd, and I'm sorry if I called you out, David, and things like that, but he's been asking about LaneNet. And LaneNet actually runs this type of program because it's important not to understand that I have a bunch of lanes, but which lane. So it uniquely defines each one of the lanes, and it uses the semantic segmentation algorithm to do this. And so then that's the advantage. So if I was driving, I want to know what lane, then instant segmentation do this. Now, if you go around our circle from A, B, C, D, a circle, that looks like a square to me. But if you go around our square, starting with A, the most expensive thing that you're going to do is instant segmentation. And a lot of times on these processors, you're going to see second inferencing on these, including your PC. So you're going to have to run something like an Xavier, and you may have to bring Tensor Rt into running those types of networks. They are very expensive. Semantic segmentation will be the second, object detection, and then image classification is the least expensive computationally. So why did I drag you through all this stuff? You're saying, hey, Steve, we're here to see Jetson. So what I want to show you is by using the CUDA approach and what we do, and simply changing a single parameter, you're able to go in and use everything in our library and get it going. You don't have to do anything specialized like with Tensor Rt and focus on model architectures and all that type of stuff. You can just run anything across all the classes that we have. So any questions? I'll open it up to some questions if we have any, or I will just move on. Yeah, we have one at least, I see. No.
I think this is just a comment for maybe. He said he likes the way you set the stage with the background.
Okay, well, thank you on that.
Yeah, and if anyone has any questions, you can raise your hand at any point in time, or you can type your question using Q&A or chat. So it's all open. So at any point, just you're welcome to ask questions.
Okay, so let's go ahead and start with the hands-on. Okay, and yeah, I think you're going to let me go ahead and get it here. So screen and things. Thank you, Komal. You're great at running this stuff. So here we go. Here's Steve's stuff. We don't really care about his notes. So let's go ahead. And what I want to do is actually find this. And so let's go ahead and get our code for today, and going up to our nice little GitHub. We have put everything in something called CUDA applications. And we have some of the information down here in the README that was shared, and then what each one of the programs can do. So let's first start with the bottle class. Well, let's download the code to begin with. That's nice to say which one we're going to start with, but let's start with this application. And let's go, or I should say, let's start with the get, and let's clone this and paste it. And here we go. So that will take some time. Now, one of the things I wanted to talk about is some of a coder out there did a really good job about getting something called Jetson Stats on. And the reason I want to go this is what Jetson Stats will show you is allow you to control your Jetson device, but also see some of the stats and info and get you an idea whether you're going to run into the problem that I'm running in being back on 4.2. So let's go ahead as we're downloading and go ahead and install that too. So I'm going to go ahead. And so what you need to do is actually SSH. So that means, log on to your board. So what you want to do is, hopefully I have it set up here. Well, I got a lot of stuff set up here. Forget it, Steve. Let's do this. So you're going to type in SSH, then your username, which for me is easy, alwaysAI, and then your host name. Now my router works on IP addresses, not hosts. So I know my IP address. You may have the same thing. I'm going to go into it and I'm going to go boom, boom, boom. There's my IP address and then, your password for your host name. And now you're onto the system. So you can see what's going on there. And so then what I'm going to do is if I want to install this Jetson Stats page, and we have it, where it's at and everything on it, but you can use your pip. And if you don't have pip, go to Discord and we'll show you how to install pip. Eric loves helping people on installing pip, so you can do that. But let's assume that you have pip for your Python environment, and we're going to go ahead and do this, and we're going to type in stats. And so we should be able to get this code. Yep, you want my password because I'm using sudo, and I just typed it wrong. So let's just go through the pain. Yep. And there we go. That's the fun of live stuff. So it's going to come through and it's going to say, yep, you're already there. But I just wanted to show you how to do it. So the next thing we want to do is enter something called JTOP, which is for JetTop, but actually do it. So now what JTOP does is it'll bring up this interface that you can see, and it'll show you what's going on with your Jetson product. So you can see right here, what's really that I'm on Jetpack 4.2.2. That's the info page. So if I went over here, I could see it even more clearly. There's your Jetpack, there's your version, there's our 9th author of the program, send kudos to him. And then you can see what's going on and what the different versions of the code, your IP address. So it's got all the different information on there. So if you come in here and you see that you're not on a Jetpack 4.4, like I'm showing, you will need to make, you'll need to make the changes, and I'm going to show you how to run the code on it. So that's what I wanted to show you. So we should have downloaded by now, even on my slow Wi-Fi. So the first thing I want to do is go into CUDA applications directory, and then I'm going to go into, so this is the fun of COVID. Let me step back, is you have to find things that are around you. So we're going to take a look at water bottles today. Okay, and so everything's taught to look at water bottles. So if you have water bottles, you're going to be fine for this. That's the other piece you're going to need. So we're going to go in and show the classifier. And so let's go ahead and run this. We'll start to set up to run this program. So we're going to do exactly what Komal told us. We're going to run our alwaysAI app configure. And so I want to create a new project. So I'm going to do that. And I'm going to call this project. What am I going to call this? I think we'll just call it a bottle classifier. And forgive any misspellings. And here we go. And so now what we've done is we created our projects, and well, we haven't yet. And I'm going to use a remote device, my Nano, and I only I will use a save device. You can go through and create if you haven't created to your Nano. I'm going to go ahead and just choose my Nano that's there, And then I'm going to create my Docker file. This is where the fun comes in. So then it does all the stuff. Now, would you like to? Yes, we're going to use that. And so the next step is, if we go into the program itself, and I want to do that real quick, and then we always use this in our app situation, you'll see a couple of things. So number one, I'm using the Google Net architecture. So I'm using off-the-shelf Google Net to do the classification. Now, and that's, let me get it, that's right here. And by the way, I'm using the most base, typing in Nano, use your IDE or whatever on the program. I'm using like the most base editor that you can in the world, and that's Nano. So anyway, so there's the model I'm running. But if you see here, what makes this different than our sample apps is the fact that to work with CUDA on anything, all you have to do is change the engine in here to DNN CUDA. And then what's interesting also is if you come over to Accelerator, you'll see I'll have NVIDIA FP16. So what this says is, let's go ahead, as we're moving the model using the CUDA APIs and everything and binding it out to the GPU, what this will do is go ahead and change it from the 32 precision, floating point 32, to a floating point 16. If you just leave the default accelerator, it's going to come in and it's going to use it's going to use a 32-point precision. So, through these two simple things, you have something now that's compressed its architecture. So it's more not compressed, but quantized its architecture. So it's more efficient. And also, it's just going to take that standard Google Net and it's going to push it in and run the particular parts that it needs to on the GPU. So that's all you need to do with a standard application to get it to work on your Jetson device. So it's really nice. Don't have to learn any CUDA APIs in coding. So anyway, so we have that. So what's the next step? Well, the next step is, let's go ahead and let me go up to our famous website. So there's our famous website. And to show you that, I should have projects going on. And you can see it doesn't got my, so there's my new project. It's been there. But let's go ahead and let's add a model. So we're going to go in our model catalog. We're going to go to classification, because that's what we're doing, a classifier. And we'll find Google in that. So let's go ahead and type that in. Let's see if we can find it. Nope, that's not good. It's very literal, our search. We'll have to work on it. So I got Google in that. And then what I'm going to do is exactly what Komal did. I'm going to go ahead and bring this down. And we'll go ahead and paste. And there we go. And so the next thing I want to do is deploy it, which in this case now, we don't have to use the word deploy. We can use the word install, just like we do if we're doing it locally. Oops, and this is going to fail. So this is where I get a little excited, and I'm going to show you how to work around the failure. I should have mentioned that right now. So
the few people in this world who get excited to fail.
Well, there we go. So spend a little time on this. Here we go. Come on, fail, fail, fail. Oops. And here we go. Unknown, right? On the manifest. So yay, there's our failure. So what's wrong with this? It needs a Jetson, a Jetpack 4.4. And I'm running, as we know, 4.2. Didn't even bother to get to 4.3. So how do we work around this? So what we do is we want to go in and edit our Docker file. I think that's what we call it. Yeah. And you'll see right here, we have this nice little blah, blah, blah. And what it does is it finds the hardware and it brings down the latest version. Now, this also can be good for people that develop that don't want to get updated. This is the other way to do it. So what I'm going to come in now and change this a little bit. So it's looking for the hardware. I know what my hardware is. I don't need the CLI trying to figure out what mine is. And then what I want to do is actually go back to our last version, which was 15.1. And if I do this in the Docker file, there should be some magic that goes on. And you'll see some, if you don't have your Docker image downloaded, it will download and it'll be much slower than mine. I've pre-downloaded so we can make it through this event, not watching Docker images come down. So now I'll go back and I've edited it and I've got my app installed. Here goes Steve, very excited Steve. And if I fail, then this will be interesting. So, and here we go. Oh, look at that. So now we're up and working. So that's what I did want to show people. So there we go. And then let's go ahead and do our app and start. And boom, we are up and running. And there you go. Hey, look at that, exciting. There's some water bottles. And as you can see, and we're inferencing about 30 milliseconds. And again, we don't know which water bottle sees or whether it sees both of them, but there you go. There's your label. There's everything running. There's your workaround. If, again, like I said, you're like me and haven't updated your OS. So let me kind of stop and say, any questions on that? And as you can see, that's not bad. That's running right off the Jetson board in inferencing time. If you do the inverse, you'll find out what your frames per second was.
So no questions.
Okay, well, good on that. So hopefully people are following along. So we'll do a similar. So now we ran that architecture using this. We'll go in and we'll do a little object detection. And because you guys have seen this before, and I bet you it's a bottle. We'll do that, and we'll put detector down. Now, in this case, and we'll do it again, we'll go ahead and do the alwaysAI configure. And we'll create a new project. And what we'll do is we'll enter the name, and let's just call it bottle detector, right? And we'll go to the remote device again. And we'll go ahead and let's go ahead and use the save device. Otherwise, we'll get ourselves into trouble. I'll be looking for something I don't have. And we'll go ahead and create that terrible Docker file that doesn't work for me. Okay. And let's go ahead and do our fun stuff here. And, once again, we'll go ahead and I'll show you on this one. Again, it's the same type of thing as we talked about. It's using the CUDA and then the accelerator parameter. And this time we're going to use tiny yellow. So we were moving from a GoogleNet architecture, doing classification over to a YOLO architecture. And I'm doing object detection. So let's go ahead, and we know what we have to do here, right? We know that this is wrong. And so what we'll do is we'll back this out. And again, the good thing about this I want to emphasize is, let's say you're in development of the project and we come out and we do what software companies do and we annoyingly upgrade you. And I think that I should have not done that because I don't remember commands anymore. Let me go ahead and exit out of this. The reason, and boom. And the only reason is I forgot, was it a dash or not? So what I'll do is I'll do this. Go ahead and move this forward. And let's go ahead. And so what I was saying is this will lock you in to what version you want. So if you come in and hard code this into it, you take away the dynamic side, but it also freezes you. And as you're moving towards production or some type of deliverable in your prototyping and everything else like that, and you don't want to see a lot of change, you're very happy, that's how you do it. You come in and you start to lock this down. And if you have any questions on how to edit this and so forth on any individual project, just go onto the Discord site and we'll go ahead and take care of you and talk you through it. So again, we got that. So now we know that we're going to need to go to our model catalog. And this time we're going to go over to object detection. And so we're still going to go over to object detection. And I'm going to search for something called YOLO. And there's my tiny YOLO version 3. And so what I'm going to do is copy that model, and I'm going to run it. Pretty easy so far. It's going to fetch it. And then what we're going to do is not play around with that. Just go ahead and install. And we should be good to go. Oh, well, what happened there? It says 015. Build fill, Docker logs. Okay, well, that's not fun. This is the fun of live stuff. Let's see if I did something wrong. I don't think I did something. I do think I did something wrong. So see that right there? That's a death knell. All right, so that, do not have that $ there. So bingo. So once again, like I said, you can tell I'm doing this live, people. Oh, look at that. You got it this time. Okay, now let's go ahead and start it. And then what you're going to see here as we come in, hopefully, is a couple of bottles being object detected. Well, you're going to see at least one. I kind of want to see 1, 2. I don't know why it's not seeing the second. Well, it's going to have a bad time. All right. Likes it when I put my hand. It sees multiple bottles on there. So there's probably some nice confidence level adjustments I need to do on that. Still not confident about it. All right, there we go. So we'll have, so basically you're getting, that's the object detection. What I show is the speed. It thinks it sees 3 bottles. I wouldn't want, there we go. Let's see if that helps. No, doesn't help at all. Anyway, so there we go. Less than success there, but it sees 3 bottles where there's 2. But it's coming in and it's pushing the YOLO through about 53 milliseconds. So remember what I said, it's more computationally heavy to do this. So that's that one. Now, let's go ahead and stop this for a second. And then let's go ahead and I'm going to go climbing over here. I don't care about that. So I'm going to go over here and I'm going to go ahead and bring back up JTOP. And so part of the fun of JTOP is, now look at, these are 1.5 gigahertz, and you can see they're floating around here and so forth. So part of what I want to do is I want to go take a look at controls. So what they offer you here is a set of controls that you can work live you can work in real time to make your system go. So one of them is like this. So if I check this, this is my power management. So now I've gone to power management 1. If I look over at, the whole system, you can see I've turned some of the CPUs off. Now, why would you do that? Well, you're trying to save power and so forth. So it's kind of a nice feature, and there are command lines you can do this, but this utility is kind of nice as you want to play around. So did I want to slow down my inference? No, I really didn't. I wanted to actually speed it up. So I'm going to go back here and click this up and get it back to running on full, so you see 4 clocks. The next thing I'm going to do is I have this thing called Jetson clocks. And this was going to kick my fan in because I'm going to run it, but I'm going to peg my CPUs to run at top performance when I do that. So I'm going to take this, hit S, and it's going to say speed 100%. And so now if we go back and we take a look at the CPU modules, we can see that they're now getting up to their top speed. I guess it's 1.4 gigahertz. I'm used to on that, but now it's starting to go in. Maybe you can hear in the background my fan is kicking in and all that to get things going. So there we go. Now we have our CPUs fully pegged. Let's go see if that makes any difference in our inferencing. So I'm going to go back over to here, and I'm going to do an alwaysAI start and see if we can drop that thing down. It may or may not. Actually, it definitely won't, because I have, I think I still have this up, and that does suck some of the computational speed out of it. So let me do that and go back over to here. And we should be able to top it. Let's see, we were at 0.53. Let's see if it helps anything to do that. No. But anyway, that's a way you can tune and play around, and you can see I didn't get any benefit out of that at all, but it does show you how to control the system. I can come into JTOP and we can see what's going on too. We can monitor, what's happening with the GPU. You can see, there you go, a lot of your computational stuff's happening on the GPU and how it's running. Bingo, and how it's spiking, how things are getting pushed across to it. Again, you can see how your CPUs are working and everything. So I'm going to go back and just set my system so that we don't have to hear the fans. I'm going to take off the Jetson clock right now, and you can see there's my fan. It's going to slow down. And if I move back to the CPU space, well, this time it's actually running a little bit higher over there. If I go over to here, you can see that I'm back saying, it's still at 1.4 on the scheduling, but it will start to calm down.
Hey, Steve, I actually have a question, if it's okay.
Okay.
When you push the program onto the Nano, and there's 4 different CPUs on there, does it push the program on all 4 together, or?
It ideally should do that with the CUDA API behind there. Yes, it should be able. It schedules across the processors.
Okay, and then that pushes that program on the GPU to do multiple processing.
Where you'll see the inefficiencies, OpenCV doesn't necessarily do that for some of the stuff that we're doing on that, and some of the presentation stuff sometimes just pegs itself to a single CPU. But that's a good question.
Okay.
All right, so on this thing, let's talk a little bit about semantic segmentation. So thought we'd have some fun. So what I want to do is show what autonomous vehicles look like. And we're going to take a little tour down the city of Toronto. Now, the Nano is not what you would use generally for this type of application. So it will appear a little bit slow, but you can do it, and you can see what goes on with semantic segmentation and autonomous vehicles and so forth. Now, you'd really want to start using, something up in the Xavier zone and so forth if you're going to try to do this in real time on it. But anyway, let's just take this for fun. We'll go over here. We're going to configure our application. And I'll try to get moving. I'm sorry, Komal, that I'm slow.
Hey, that's okay. You have plenty of time.
We'll just call it auto. I'm going to do that. Create my project. It's going to do all the fun stuff. And we're going to still go to that remote device, and we're going to go to we're going to use a save device. And the Nano. And we're going to create this wonderful Docker file that we're going to go edit. So now we've gotten an idea that we're using semantic segmentation, and we're going to use something called the ENet model. The ENet model is one that's in our catalog, and it's the one most used in autonomous vehicle applications. And the reason it's the fastest, most accurate model there is out there. And we'll go ahead and add that model. But first, I'm going to edit my Docker file so that we don't see the failure. And we'll get it right this time. A lot of promises there by me. And we'll come in. I'm going to call this a Nano. And that is just about it. 15.1. So get to see more than you thought you would on it. So let's go ahead and go back to our model catalog, and we'll go back and we'll go in here. Click to the home page. We'll go into semantic segmentation. What's interesting, you'll see something like this FCN. Now, Berkeley, University of Berkeley, California, was the first to really start working these. And these are called fully convolutional neural networks. And that's what semantic segmentation does. Remember, we are going in and we're classifying each pixel. So in other convolutional neural network architecture, you have things like pooling layers and other layers that do things that are not necessarily trying to converge the model or doing what I would call back propagation and gradient descent type of algorithm. On a fully convolutional network, there is none of these pooling layers and so forth in it. It's all convolutional that goes on. And so based upon that, that makes it highly computationally intensive. So we'll go in, and what we're going to use is the ENet one. And what we're going to do is copy that, and we're going to go put that into our install because we want to add that model. And of course, that's our application is looking for this model. So we'll bring down the ENet model. And Eric said this didn't work earlier. Eric, yes, it does. The model is there. So alwaysAI app, and I'm going to do the install at this point in time. All right, come on, copy, 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 copy. All right. And so let's start this. And let's start this. It takes a while for it to load the model into the GPU. All right, so we have that, and now we're going to see, we're going to go driving through Toronto. We're going to go driving through Toronto. There we go. And as you can start to see here, and I'm sorry that it doesn't display better on this, but you can see your sidewalks. It truly is, and you can balance what the mass looks like, and it goes over. But if you look at your, as you're running this program, you look at this thing, you can see it truly is like picking up the cars, the sidewalks, the pieces. You can see that it's you know, it's pretty computationally hard. It's a little jerky, but this is running those things. And now it just, I pushed the stop button. I apologize on that. I shouldn't have done that, or at least my client lost connection. And there we go. But you can see up here that now, you know, you've taken this processor, you know, to about almost 300 milliseconds to process. That drops down as you get up in the Jetson family. But this is, you know, what drives a, this is, you know, what they're using over at Tesla, and as its base. And so again, you can see it's classifying most of the stuff up there if you look at it, the cars and so forth. And again, we have parameters where you can tune the mask that it's a deeper mask than it is right now, but it's overlay so you don't get as much noise. But if you look at it, it's doing a pretty good job, sidewalk, people, and so forth. So that's what semantic segmentation running on a Jetson. Again, if you want a better experience, you need to go ahead, probably the Xavier line of processing. And so forth. Now, these are hard to annotate. You know, obviously, it's not like doing an object detection. You're going to have to annotate each and every, you know, you're going to have to use annotation that takes count for all the pixels and everything else like that. But that's going ahead and taking a drive through Toronto using a Jetson Nano and so forth, and semantic segmentation. One of the neat things we have, if I go over now to our docs, in semantic segmentation, and we'll show you that on semantic segmentation. Where is my semantic segmentation? No. Semantic segmentation. Wow, thank you for making these better. Docs, there we go. That's embarrassing. But anyway, one of the things, you generate a class map, right? When you come out of this, and it says this is the class for each pixel. But within this, we have another algorithm that, and you build legends and everything, but we also have one where you enter a class map and then a class list, and it will put all of the classes that aren't in those class lists back into the background. So it'll allow you to do semantic segmentation to identify different classes and so forth in it, and push the other stuff to the background. And that can be interesting as you start to go to the point cloud and you want to see a segments of points. that you want to find distances to an object and so forth if you're doing spatial AI and so forth. And we'll talk to you and show you that stuff later. I got, we'll go in and I'll show you that with the bottles. Hopefully I will have just 2 bottles.
Steve, is it okay if we stop really quick for a couple questions?
And we'll go into bottle segmentation. And this
Steve,
again is semantic segmentation using that filtering API on the mask. And so we'll start with configuration, and I promise I'll be getting it done soon. I think that's right, configure. That is made up word that I did there on that command. So we'll create our new project. We'll just call it bottle seg. And we'll configure that. And we'll go ahead and go to the remote device. And we'll use the save device. It's pretty repetitive at this point in time. And yes. And we'll go ahead and alter the Docker file. And again, we have this thing, we have all of our starter applications and things like that. You can move those all into CUDA using that basic command that I showed you in the piece of just changing the accelerator and the constants. Let's go ahead and get that Docker file again and do our little thing. Probably sick of seeing this, but anyway, you know what to do if you hit that issue where it bombs out. So I want to thank the alwaysAI development team for letting me do this today, for releasing on the day I have a hacky hour. All right, so anyway, so the model we're going to use on this one, if we come back to my catalog, where did I put it? Yeah, we're in semantic segmentation. Let me go over and go to model catalog. There we go. And semantic segmentation. So the model we're using for this one is one of the Berkeley models, and I believe we're using the VOC. So the VOC is 20 objects, and one of which being a bottle. And we're going to go ahead and use that for our semantic segmentation. So I'm going to go ahead and copy. I said pretty easy to experiment and get started with a CUDA. You don't have to read tons of documentation and learn APIs. And that's always a good thing. So we made Eric do that piece for us. Yep, and we'll go ahead and do the install. Oh, pull access denied. Wow. What did I do wrong? Oh, you know what? I know what I did wrong. I can see it. All right. So this is, and so we all could see what I did wrong. I got a little bit too vigorous there. And so we'll go ahead and I guess this is a good thing. I can show you everything that shouldn't happen. And we'll go ahead and we'll try again. And I picked it up right there. I could see that on this thing, it didn't have the colon that it should have. So, like I said, the hazards of going live. And there you go. I'm just going to install that in. Install that in. Big models, these guys. And like I said, heavily computational. But interesting on those. So come on, you're taking away my small talk. Install, please. All right, I guess it's time to ask for any questions as we're sitting here installing.
Yeah, Steve, can you hear me?
Anything, Komal, on this? No? All right.
I think
dead air.
I think your speakers are off. Hello?
Uh-oh. Komal, can you hear me at all?
I can hear you. Can you hear me?
Hello?
Hello?
Oh, my speakers went to mute for some reason. Hey, Komal, can
Okay,
you hear me now?
now?
Yeah, I can hear you now. Sorry about that.
Okay.
I could see a ton
No,
of
all
questions
good.
up there, and I'm just cruising because I clicked the mute button on my speaker. So I'm having a good day, everybody.
All good.
Well,
Is it okay if we take a break for a couple questions?
yeah, absolutely. It sure was. I'm sorry, people. I just plowed through. I clicked the mute button accidentally. So,
All good. Okay, so we have our first question from AB, and he asked, can we use AAI on a laptop with NVIDIA GPU with CUDA installed? And he specified it's Ubuntu 18.04 with CUDA installed. And he's asking, can you show us what changes needed to be made on app.py to support that?
So, okay, I'll show you that, but we only support the Jetson family today. So that means we're not supporting things like the laptop yet. But definitely put a feature request in Discord so we can take a look at doing that. So that seems like an important thing. Now, the caveat to that is on model training. We do train on the GPUs. So the model training team already has that active. We focus specifically on the Jetson because we're an edge company, but definitely put a feature request in on that. That's a good thing to do. So.
Okay.
And so the last thing was, can I show you what's going on in the app.py? So let me go ahead and see if I can do that. I just blanked out. Oh, my TV just booted. Having fun, or my monitor just booted. So let me go ahead and show that. So let's go in and let me share my screen. Okay, share screen. And let's go in. And again, I apologize for running all over your questions. I just didn't know that I was in my own little world. Okay, so let's go in and we can just do it here. So again, on the API, if you're going to a Jetson, this is the case. So what do you want to do? And let me go ahead and I'm going to bring this full screen. Can you see my screen? Come on.
Yeah.
Okay, so all you do is when you're loading, and it could be object detection instead of semantic segmentation or classifying, is on the engine, you instead of you specify DNN underscore CUDA. Now, if you want to compress, right, go to a floating point 16, then you type in this accelerator command, which is right there, and it'll be in all the code that you want to put it to NVIDIA FP16. Otherwise, it stays at a floating point 32 precision. So you get a little bit, you lose some precision, but not much. You gain some inferencing time. And let me kind of go over to the docs. And docs. And where all this stuff is documented, how you can move into different accelerators, is if I find constants. And there we go. You go into constants. So the standard constants is just DNN, and we have that, and that just is going to use the CPU. But if you go in and use something called DNN CUDA, that's where that's how you do it. And it's just a standard application from all, on our starter apps, or if you want to pre-configure, go up to, the GitHub, and we have a couple on it, but that's it. Now, what you're going to learn from Eric next week, and you can see the default, which is 32, and the accelerator and FP16. Next week, what you're going to learn about is Tensor Rt. And so that's the other thing. And again, it's a similar type of system. And so what you can do is, instead of saying CUDA, you're going to say Tensor Rt. Now, here's the caveat. Remember, we talked about optimization. When you're using the optimization approach, which is interfacing with the CUDA APIs, I'm able to do the whole plethora of models, which we're seeing today. When you do Tensor Rt, you're limited to Tensor Rt types of configurations that are out there, or models. And so right now we have one, it's in pose estimation, and then the object detection models will be out next week, provided Steve does his work, which I'm doing. It's there, so nobody worries. So we'll show object detection. Now, what you'll see on those is those babies are going to fly. So you're going to see inferencing times in the 20 milliseconds and so forth. And everyone say, well, I've heard that they run at 130. You have to find industrial cameras. So the FPS is on these basic webcams that we're using is 30. Movies run at 33 FPS. webcams you get from office supplies or things like that are running at 30 frames per second. So if you're inferencing at 24 to 28, depending, 24 for the nano device, 28 up there, you're running line speed basically, and that includes image processing. There's not much you can do unless you want to go to industrial camera like the RealSense camera, where you're going to have 90 FPS capabilities on the camera. So your camera becomes your limiting factor when you start to hit the Tensor Rt models. So anyway, sorry, that's a lot, but that's a quick explanation. Next one on the one.
Okay, so the next one is from, I think you actually addressed this a little bit, but maybe you could elaborate. So this is from Jeff Zika, who asked, what is the maximum rate you've seen for semantic segmentation on the Nano for one stream? Oh, and can this support two streams? Like, what would be the maximum frames per second or frame rate for two streams?
So again, this is heavily computational. So as you add, and I'm going to assume streams means I want to do multiple cameras and multiple going through that, just to say if I got it right. You'll probably half it as you add strings. So if we're looking at around 300 FPS, I haven't run this on an Xavier yet. Eric's going to show you the difference next week. He's going to run them across that particular autonomous vehicle on the Nano, the TX2, and the Xavier. And but as you add streams, it's probably going to half the process. What I shouldn't say half, it's going to increase it, double the inferencing time. So the max you're going to see is about 330 and so forth on something like the eNet. Let's go ahead and see what it's going to throw out on this one, right? So on this particular one, I want to make sure I did add the right one. Let's go ahead and start this baby. And this is something you would see. The eNet is doing what we call a cityscape data set. So obviously we can figure out what that means, right? A cityscape data set, which is a pretty big one, is an annotated one to walk around a city and city formats. And that's what we were running on the autonomous vehicle. On this one, we're going to run what they call VOC, which is a visual object contest, which is a subset of the COCO database, which was used a lot in object detection. This only finds 20 standard types of objects. So let's go ahead and run this. I think it's going to be a little bit faster. So it depends what you want to do. Cityscape is going to be pretty heavy. So let me go ahead and make sure. I hope I have everything done. So you can see we only have a couple of things like TVs, things like that. So let's go in and take a look. That was that one. Here we go. And see, we're just detecting the bottles because I'm adding the other one. Your inferencing is at 60 on this particular type of model, is about 67 milliseconds. So like I said, if you doubled it, you probably wouldn't see it increase that much, but on the fully convolutional networks like that are doing something like on the Pascal or COCO database, that's what you're going to see on it. That's not bad. That's pretty fast. Let's see how quickly I can get my hand in there. See, my hand comes in pretty quickly into that system. So it's rocking and rolling. Your Pi would probably be dying right now. It'd probably be on fire. This is what we got. I want to point out, you're going to say, but Steve, these aren't really great masking. And that's true. And so if you look at Lila's program, that she has something called, I think it's green screen background. She uses erosion and other techniques to get that better. So if you're going to do this, go ahead and look at Lila's blog, and she'll show you how to actually make these a lot sharper and clearer as you tone in on it. And she uses some of the OpenCV techniques to do this. This is me just kind of doing something raw here. So, all right. So there we kind of go. Should we go and do instant segmentation or hit some more questions? It's up to you, moderator man, woman.
I think let's take one more question from Jeff. He's asking, do you have a GSD streamer or a deep stream plugin?
So what I'm using is a standard webcam, but we do have a G streamer that works with the CSI system. So, all of our camera systems are available, but it's always good to go look at the different. So let me see where we have that. utilities it should be. Where's utilities? Sorry, guys, this is really not at the speed that I want to do this at. These are good questions. So I wish I had Eric here on me because he knows these things. Debugging with the stream, storing video clips. Where is it? Playing videos from a file. No, capturing videos from a webcam. So it should have all the different things you can do. If we go into this, different streamers. So there is one for, so you can see you have the GStreamer video class right here. So go in and this class will tell you how to use that and then tackle the CSI camera from it. So we do have the GStreamer plugin stuff. If you want to go run it, you have to specifically call it out. So with the, instead of calling the webcam, you call it the Edge IQ video streamer. And then I do believe, I'm trying to find the parameters, cam, integer. Yeah, so I think that should do it. There may be something that Eric will be able to answer. Yeah, actually, Eric doesn't need to answer it. If you're using a Jetson CSI camera, here you go, Edge IQ Jetson video stream. And that is exactly what you want to use right there. And that will work the CSI camera. So I think that answers the question. Yes, we support CS cameras on the Jetson platform. You just can't use the generic webcam. You have to go out and use this particular API. And that, I'm glad somebody asked that question. I'm using a standard webcam, but you can use the CSI. You just have to call the Jetson video streamer, which of course is it is using their GStreamer driver down below. Okay. Long question, but the answer is yes, and we have the API for that.
Okay, 3.
And then the last thing I did want to show you guys, and I know we're at that time and I overran, and so I'm sorry, but I'll show you bottle instance real quick, and I'll make it quick.
Okay.
So this is instant segmentation. It's coming out at the end of the month. It's the most computational because what it'll do is object detections with masking, and it makes several passes across the image to do it. So with that said, we'll do an app configure, and then I'll answer the rest of the questions. And again, I'm going to have to, my time management was bad, so we'll work on that. Create new projects. Let's just call it instance. And then we'll go ahead and do all of our stuff. And again, this is the one that lane net and everything we're talking about, where it uniquely identifies an object. So we'll go in and we'll use a save device, and we use nano. And let's see what we're going to do here. We're going to create that bad Docker file. Thank you everybody for that. And you guys are probably tired at this point in time, but yeah, I'll upgrade my operating system before I ever do one of these hackathons or hacky hours again, and make sure I don't mess all you guys up. But like I said, there is a lesson learned. And again, if you want to hold during development, that's you start to go to these hard coded things. So let's go do that. And we want to do an install. And because this is a prototype, the models aren't in our catalog, and I have the model embedded in the program. So this is what we call a mask RCNN type of model it's going to run. So for those that want to know what the model is underneath, that's what it's going to be. And we'll do an alwaysAI app start. And again, this is something we're going to have near the end of the month. Yep, there you go. Your RCN model is loading and set to CUDA back in. So you get to see a prototype at work. So let's see if we can get this out. And there you go. So you see now it's putting the thing, it's uniquely, it does bounce, but it says, here's your bottle 1, has one color for it, and bottle 2, and it's going to bounce around on me. But that's instant segmentation at work. And this is, you can stable it out and so forth, but this is what you'd use to identify a lane uniquely, David, as you're building that thing. And I promise that I will take a look at getting lane net in as one of the models as we bring instance segmentation. Now, you do want to, this is probably running, we'll do my hand thing again. And you see how long it takes to get the hand in. It's probably running about a second or so, a little bit slower on that on doing inferencing. So this is quite computationally heavy, and you're going to want to run this probably in something like a Tensor Rt and do that, and definitely with a higher end system. It will even take 1 second on your laptop. It's like I said, it's very computational. Bit long today. Apologize for those who've taken the time. I know it. So let's go to questions. But then you got to see we ran across everything in our portfolio, and some we don't have yet. So
yeah, and we need to change the spelling for instance segmentation.
Yes, you missed that yesterday. You missed that. So I'm really bad at spelling. So when we do all the practice session, what happens is that Komal gets me going on stuff. Same with blogs. I make up words, people. So.
Okay, one more from Jeff Zika. He's asking, do you replace N Vargas?
What was that now?
He's asking, do you replace N Vargas? Jeff, do you want to elaborate on your question?
Yeah, we'll have to have him elaborate. I'm not sure. I guess I'm dumb right now. I don't know what N Vargas is. So.
Jeff, you there? Okay.
So sorry, Jeff. Hopefully, go ahead.
Yeah, I think let's give him a minute, see if he can talk. If not, the next question is from AB, and he's asking, can we have multiple camera streams on one streamer?
I've always seen it one-to-one. I mean, I think if you're talking about streaming IP, I have to defer to Taiga on that, but I've always seen cameras one-to-one on their streams.
Okay.
That doesn't mean that's the way it is. It just means that's the way I've seen it. So we'll have to put that one out there, do a follow-up.
Okay. Yeah, unfortunately, Taiga's not on the call. So yeah. AB, I can get back to you on that question.
Yeah, it's a great question.
Okay. All right. That's all the questions we had. Jeff, this is still you still have a shot if you're here.
Yeah, he probably used so Jeff's questions there. So let's go ahead and do what people do in modern world. Let's Google this baby and see what it is, because I don't understand the term, and it and it's my ignorance. And so let me see what goes on there. See what it is.
Yeah, and Jeff, you're actually unmuted if you want to chat.
Oh, okay. This is a Raspberry Pi daemon, critical feature. I'd have to look into this and pass it on to our guys that are more camera experts. Okay, so so this is something we're going to have to get back to Jeff on it. Okay. I see what he's asking about now. Thanks for bringing it up, Jeff. I'm just not sure on that, and I think so I will take a look at it. And I think that you're asking that in regards to the Jetson API that we showed. Is that correct? Just you can type out if that's what it's in regards to. Are we replacing it?
He said yes.
Okay, so let me go ahead and we'll answer that one as follow-ups as we come in. And the answer is I believe so. I'm sorry I didn't know this to the detailed level. As you can tell, I'm not the camera guy in the group, but I will get back to that on it. And again, I appreciate everyone's patience in going through this today on it and so forth. So.
And AB has raised his hand as well.
AB, how are you?
AB, you're welcome to chat now.
Hello, can you hear me?
Yeah, we sure can, AB.
Yeah, I think that is the parameter we passed to that Jetson video stream, I think, for GStreamer and now.
Okay.
So I think that was what only I wanted to say. I think since he was not able to get into the audio channel,
So then definitely I would say that you could tell I didn't work on that API AB. And I think what would be said is that API is replacing that functionality then.
So I think internally, I think it is used in that API, but it is better to get confirmed from your team. I
Yeah.
think.
Yeah.
Because I was not aware of this Jetson video stream API from Edge IQ, and I was having terrible speed, like 1 frames per second or something, which I was not convinced why it is happening, because I'm using CSI camera myself. So I was trying to I wrote a sample code to just use the GStreamer draw API, and it was working fine. But then I think on Discord, Eric told me about this API. So,
Okay.
So yeah, definitely, I think you can check it out and let us know. But mostly, I think it uses it. I think so.
Yeah.
I may be wrong.
And, yeah. So maybe what I think I'll do based on the questions here is I'll ask Eric if he can set one of the systems up when he does next week's hackathon with the CSI camera. I think that would be probably a good thing, because that's a great question that's coming through on that.
Yeah.
Sweet. All right, thanks, AB. Any other questions from the group here? Okay, I think there's no additional questions. And thank you so much, Steve. That was super informative. And I learned a lot. I hope all of the attendees here learned quite a bit as well. Again, we do this every Thursday. So next Thursday, we're actually doing a 2-in-1. So we're doing a webinar with NVIDIA. And I'm going to share a link to that here just now, so you can register if you haven't done so already. So at 10 a.m. PST time, we're doing a webinar with NVIDIA. So you're all welcome to join. And then next week, Hacky Hour is focused on Tensor Rt support. So Eric will be leading that Hacky Hour next week. So make sure you join at 2 p.m. and we look forward to seeing you then. Thanks again, Steve. And thanks everyone for joining. Have a good one. Bye.
Thank you.